Right, hello students. In this video, we're going to explore the product rule and the quotient rule in the chapter on differentiation. And I'll try to make these two rules easy for you. All right, before we plunge into learning the product rule, I think it is important that we learn the rationale behind having to learn the product rule. Supposing you're given this function y equals to x squared times bracket x plus 1 to the power of 4, based on the existing knowledge that we have on chain rule and power rule, how do you think we can find the derivative? Yes, you would have to expand your bracket x plus 1 to the power of 4, right? Remember, your power rule works this way. So therefore, we will need to expand every term into this form, right, so that we can apply the power rule, which means I have to keep expanding it. Or you can use binomial to expand. That would be very tedious also. Right, and you keep doing until finally you have all the individual terms in the form x to the power n. And that's where you can do your dy dx. Right, so you find that this process is rather tedious. And what happens if this power gets very big and then you have a lot of expansions to do? So therefore, that gives you a reason, or give us a reason why we learn the product rule. So how does product rule works? Right, so product rules, the first steps actually are similar to what we have learned in deriving the chain rule. Remember the steps that we have learned on how to apply the chain rule? There are two terms here basically, okay, two separate terms. One is the x squared term, and one is this. So we let the first term be u, and then we find the derivative. Then we let the second term be v, and we also find the derivative. So finding derivative, I will not go into a detail, okay? I expect that you know how to do it really, okay? And then that would be the formula. That is the product rule formula, which you have to remember it. So basically, it's just dy dx, that's the derivative, equals to u times the derivative of v plus v times the derivative of u. Okay, so let's substitute in your u, which is x squared. And then the dv over dx is this value here. V will be this one here. And then the u over dx will be this one. Okay, so we plug everything in. All right, so the next step is a bit complicated. Complicated because we will have to take out common factors. Right, so you have to be a bit careful when you take out common factors. Let's do the easy part first. Easy part, because if you were to examine this one, I have 2x here, right? Here I have 4x squared. So 4x squared is basically just 2x multiplied with another 2x, right? So therefore, my common factor for 4x squared and 2x, right, will be, common factor will be 2x. Okay, so bear this in mind first. And then for this term here, there are 3 of them. 1, 2, 3. And this, I have 4 of them. Okay, so my common term will be 3 of them. Okay, my common term will be 3 of them. All right, so bear this in mind, because the next step will be we need to take out our common factor already. Right, so we agree the common factor will be 3 of this. Right, just now we have 1, 2, 3, and this is 1, 2, 3, 4, right? So common factor is 3 of them. That comes to here, right? Okay. So once 3 of them come to here, then this is gone from here. And remember what we said earlier on, 4x squared is 2x times 2x. Common factor is 2x. So what I'm left is only 2x. The common factor will be this one and 2x. So for the first term, I have taken out all the three of them, right? This one, taken all the three of them already, right? So there's nothing there left already. But 4x squared, I'm still left with 2x. Okay? Then for the second term, there are 4 of them, right? If I take out 3 of them, I still left with 1. And the 2x come out here already. Okay? So this is how you take out common factor. Right, and I need to simplify the one inside this bracket here. Okay? Right. When do we not use the product rule? Usually when we learn something new, all right, we're very excited. We're all very excited that we will want to keep using it, right? But in some situation, we can still use the power rule and the chain rule. The questions may look a bit complicated, right? But before you jump into using the product rule, always simplify the expression and ask yourself if you can just use the chain rule or the power rule, all right, before you use the more complicated product rule. All right, so what are summed functions that you can simplify? For example, if you're given y equals to x squared times bracket x plus 1, this one you really don't have to use the product rule because you can just expand it. Simple expansion to get x cubed plus x squared. And there you can just use your power rule. All right. Another example is, yes, and then you factorize the common factor, which is x. So you take out x bracket 3x plus 2. Another situation is this. This may look a bit complicated to you. You may think that, hey, I think I need to use the product rule because there are 2 terms here. But actually, if you were to recall that one of the rules you learn in the chapter on surds, if you have square root a times square root b, you can actually multiply them to get square root ab, right? So here we are referring to the same. We're talking about square root x times square root x plus 1. Okay, so we can actually multiply them, right, to get square root x squared plus x. And we convert the radical into power. You need to convert it to the power, then you can use the chain rule, right? And then from there, you can just use the chain rule. All right, so the next step is that convert this back. Okay, this one is index form. Always convert it back to radical form. It's easier. Right, so this one I would expect you to already know it. If you don't, then please go and look at the earlier video. There's an earlier video on how you should prepare yourself before you do this chapter on differentiation. Okay, so this one you can convert to a positive index will be this. And then convert it to radical form will be this. Okay? Right, and that's it. So there's no need to use the product rule. So make everything as fraction. This one I've already explained to you how we do it. Okay, here. And differentiate x squared, you get 2x. Differentiate x, you get 1. So basically, the derivative of this will be 2x plus 1, but you make it as a fraction, is 2x plus 1 over 1. Why would you make it as a fraction? Then you can just multiply your numerator, which gives you 1 times bracket 2x plus 1. That gives you 2x plus 1, and then multiply your denominator. That's how we explain this one here. Okay, so for situations like that, please do not use the product rule. Try to always, okay, the rule of the thumb is always simplify the expression. If you can use power rule or chain rule, go ahead and use it first. Okay. All right. So having learned the product rule that's applied, okay, let's do one easy questions. If you look at the functions given, obviously you can't really simplify any further because this chunk is to the power of 4. You're not going to expand it, right? Don't do that, please. You're not going to expand it. So here we just have to use the product rule. So step number 1 is to let u equals to 2x to the power of 4 minus 1, and then v equals to the second term, and let's go ahead and find your du over dx. All right, always simplify it. Don't leave it as 2 times bracket 4x cubed. Simplify it. If you have done the simplifications earlier, right, you'll find that the last few steps is more manageable. It's like what in Chinese they said, 先吃苦才后甜. You do the difficult part first, okay? and then the last few parts will be stricter for you. Then you do dv over dx. Okay, right. I will really encourage you to use chain rule. Always write down the second steps times differentiation of your whatever inside the bracket, because this is a part that a lot of students always forget. So it's good practice to write it times differentiation of that. If I know it's one extra steps, but sometimes the extra steps will save you. Okay, right. Then you write down the formula. That is a formula. Okay, so we plug in your I think I've not done this, or maybe later on it will just, I'm not too sure. So we differentiate 5x plus 5x plus 6. Differentiate 5x, you get 5. Differentiate 6, you get 0. So basically this is just 20 bracket 5x plus 6 to the power of 3. Oh yes, okay, it came out later. Okay, right. Okay, maybe that is the reason why I never take 4 times 5. I leave it as 4 times 5 because there will be some common factor, okay, with the some other terms. But you can just also do it this way. Doesn't matter. You can just leave it as 20 bracket 5 plus 6. Okay, so the next step for product rule, the difficult part is coming up with the common factor. Okay, coming up with the common factor, that's the difficult part. So let's examine. There are 3 of them here for this guy. For this, 4 of them. Right, so the common factor will be 3. Right, 3 of them. And then if you were to look at your 8x cubed and your 4 here, then the common factor will be 4, right? Okay, so let's do one step at a time. Yes, let's take out your 4 first. And then we take out the 3 brackets just now I mentioned. So these 2 will be your common factor to pull out. Okay, then we go back to the first term and see what is left. All right. So basically, I've just taken out all the 3 of this guy here. So this is gone. I take out 4 is gone. So I'm left. What am I left? Yes. Okay, you're left with this and this. Then if you go to the second term, there are 4 of them. 1, 2, 3, 4. I've taken out 3 of them. So you're only left with 1 of them. I take out 2 from 8. Sorry, I take out 4 from 8. So I'm left with 2. X cubed, I didn't take out any x. So x cubed is still there. Okay, and of course this one you will have to expand it. Right, simplify further, and there we go. So that's the answer. Okay, all right, so the next one, it's I would consider as intermediate. Why intermediate? Because it sees that there is a radical of square root 1 minus x squared. Anything to do with like cube root x or square root or the 4th root or the 5th root, that usually is harder. Okay, so let's do the first step. Don't skip the first step. Okay, until you are very, very good. But usually, most of the time, I would just advise you to still write down all these steps. Because sometimes in the exam, you may think that, yeah, you may panic and things like that, and then you maybe just make mistake without knowing. So it's always good to still write down all these steps. This is the power half. Change it to index form. All right, so let's do the derivative for u. Differentiate x cubed will just be 3x squared. Differentiate 2 will be 0. Let's do the derivative for v. So it's dv over dx. So step number 1, put down the power. Step number 2, power minus 1. So half minus 1 is negative half times differentiate what is inside here. Okay, I'm going to do it simultaneously. So this will be half times 1 over. All right, 1 over bracket 1 plus x squared to the power half, right? Change it to radical form will be just square root 1 minus x squared. So this one you must be very proficient in it, okay? So please, if you're not, then go and revise the chapter on integers, how you convert from index to radical form, from negative index to positive index. Okay, differentiate 1, you get 0. Differentiate negative x squared, you get negative 2x. Put it as a fraction. All right, so multiply the numerator and denominator. So take out the negative. That will be 1. Okay, can you see that this 2 and the 2 can go off? So basically what you're left at the numerator is just x. And then denominator is just square root 1 minus x squared. Okay, be very careful when you're doing this part here. All right, so now let's write down the formula. So the derivative of f of x will be f prime of x. Okay, depending on what you're given. If you're given f of x, then the derivative is f prime of x. No longer dy dx. Okay, so the formula is u dv over dx plus v du over dx. Okay, that's plug in your u, which is bracket x cubed plus 2. dv over dx is negative x over v. It's change it back to radical form, so it's square root 1 minus x squared. du over dx is 3x squared. Okay, so here comes the tricky part again, because we need to combine them into one single fraction, right? So again, put this over 1. Okay, so you see that my denominator for the first term is this guy here, which means I will need to multiply this with 1 minus x squared and also on top. Okay, and then I combine them into one single fraction, one long line, where the denominator is square root 1 minus x squared. Okay, so there's a negative there, so negative x times x cubed plus 2. Be very careful, do it slowly a bit. You know, first time doing it, you just have to be a bit careful. Okay, you can see that I'm doing it very carefully because I don't want to redo. Right, so if you take this times this one, the square root will be gone, right? So that will give you plus bracket 1 minus x squared, and then times another 3x squared. All right, so that simplify. Let's open up the first bracket. That will give you negative x to the power 4 minus 2x. Second bracket will be plus 3x squared minus 3x to the power 4 over. Okay, I'm going to continue here. Right, so the numerator will be negative x4 minus 3, so there will be negative 4x to the power 4 plus 3x squared minus 2x. My denominator will be, okay, I can still factorize something from the numerator. That will be x, so I can just take out x. So they give us negative 4x cubed plus 3x minus 2 over. Okay, so this is how you do an intermediate versions of the product rule. Right, so the next thing is that when do we use the quotient rule? So we're done with the product rule. So quotient rule is given, it's used when you're given a fraction. Just now, the product rule, what we're given is the questions is in the form a times b, right? Where your a and b are some linear factors, not necessarily linear. Sorry, it's just example. Okay, like in this form, right? Something times something, right? So you use quotient rule when you have something divided by something like a fractions. Okay, algebraic fractions. This is called algebraic fractions. Okay, and if that's the case, please don't convert it and use product rule. Usually that is the reason why we use quotient rule, because it's easier, right? So in different situation, we just use differently. Like some situation, you can just use your power rule, and then some you just have to use combinations of power and chain. Some you have to use product, and in here, this situation where you're given an algebraic fraction, we use the quotient rule. So what do we do? So basically for quotient rule, you just because a fraction will have numerator and denominator, So you just let the numerator be u, denominator be v. U come first, right? A, B, C, D, E, F, G, H, I, K, U, V. Yeah, so U come first. So U go to the numerator, V go to the denominator. Right, so you let U equals to X. So the du dx will be 1. That's easy. And then you find the derivative of V. Okay, this part is easy. Right, so that will be, so your formula for your quotient rule. So this is the formula for your quotient rule. All right, so you just have to memorize it, and it's not difficult lah. If you look at the first part lah, first part is your product rule. Modified, because your product rule, this is a plus, right? But for quotient rule is a minus. And for product rule, you don't really have to worry whether you write dv over dx plus, or you write this first, right? Because you're just doing addition, right? You're simply adding them, so that's fine. You can, whatever position, whatever terms you want to write first, doesn't matter, right? But here for product rule, it's very important. You start with v du over dx. It's very important. You must start with v dv over dx. Otherwise, your answer will be wrong. Okay, so we start with v du over dx, then minus u dv over dx, then over v squared. Okay, right. So that plug in the terms, huh? All right. So v will be bracket x plus 1 to the power of 2. Du over dx will be 1. U will be just x. dv over dx is 2 over v squared, which is just x plus 1 to the power of 2 and then to the power of 2. Right, so that simplify. So I will get x plus, okay, I need to expand. Don't need to expand. If you see there's a common factor, can you see there are 2 terms here and then this 1. So I can just basically take out one of them, right? So I take out one of them will be just x plus 1. If I take out one of them, I'm left with one of them. And 1, of course, is still 1. I don't have to keep writing it. And then for this fella here, I take out the only one there. So I'm just left 2x. And of course, 2 times 2 gives you 4. So the new denominator is x plus 1 to the power of 4. Okay, simplify the numerator. Negative x plus 1. Oh, and can you see that I can simplify further? Because this guy here and this guy here, okay, I can simplify it. I can just basically cancel off one of them to get bracket x plus 1 to the power of 3. And if you're not happy about writing negative x first, you can just change the position, write 1 minus x. All right, and so this is quotient rule. All right, this is quotient rule. Right, so let's do a more complicated one. I will consider this as an intermediate question. So first step is we let the numerator be u, denominator be v. Right, so step number 1 is let u is equals to x. V equals to square root 3 minus x. So our du over dx will be equals to 1. Change this to your index form. So that will be dv over dx. Bring the power down. Power minus 1, that is negative half, times differentiate whatever is inside a bracket. Please don't skip this step, okay? This step is important, otherwise you will forget to differentiate whatever that's inside the bracket lah. Okay, so this will be half times, change this guy to 1 over square root 3 minus x times differentiate 3, you get 0, differentiate negative x, you get negative 1. Okay, so that will give me negative 1 over 2 square root. Okay, always simplify. Okay, like what I mentioned earlier on the Chinese saying, 先苦后甜. Right, then your dy over dx will be, the formula will be v first, du over dx, then minus u dv over dx over v squared. Okay, so v is my square root 3 minus x. Du over dx is 1. U is my x. dv over dx is negative 1 over 2 square root, then over b squared. Okay, so this is the tricky part. All right. Some of you may want to take out common factor like 3 minus x to the power of negative half, that kind of thing. I find it very complicated to me. I find it's easier you just do this simple trick. This simple trick works magic. You just look at the term that has a fraction, algebraic fraction. So the term that have an algebraic fraction will be this one here. And then you zero into the denominator. The denominator is this. Okay, so all you need to do is just multiply every term at the numerator with square root 2, 3 minus x. And of course, also at your denominator. So this one you need to practice, okay? It may seem very easy when I explain to you, but you really have to try it on your own. Okay, so the next step, you have to be careful, all right? Be very careful. We are basically taking, if you are worried about doing wrongly, you just write it out. Like what I say, the extra steps will save you. Okay, negative times negative become positive. And then you can just leave your x there if you want, doesn't matter. All right, so the one below will give you, okay, you can leave it as this, v squared. Okay, when you square root is gone, so you have 2 bracket 3 minus x, and then square root 3 minus x. Okay, you can leave it as like that. Or you can simplify it later. I'll teach you how you can simplify further. Okay, let's go on with the numerator. So the numerator will be 2. The square root 3 minus x times square root will just give you 3 minus x. And can you see it work magic here? That these two guys will be gone, so you only left with x. Over, I don't think you're expected to simplify this, the denominator, but I will teach you how to simplify more if you want to. Numerator, definitely you must simplify. That will give you 6 minus x plus x, so 6 minus 2x plus x, so 6 minus x. Okay, below, if you want to simplify, or below, my god, what's below? Denominator, this one is the power of 1, right? The other one is the power of half, right? If you want to simplify further, it will be 3 minus x to the power 1 plus half, they give you 3 over 2. And if you're still not happy, you want to change it to radical form, there will be square root, then 3 minus x to the power of 3. Okay, so that's how we do it.